So please read out what you have there. That is under that determination. That's page 138. Read out what you have. Determination of what?
Of the modulus of material of the wire.
Let me see that page 138. Yeah, they gave us length to be 130 cm. They gave us diameter to be 4.0 plus or minus 0.2 times 10 raised to the power minus 4 cm. Okay, so please, I want us to do three practicals at the same time today. So then I have determination of, so we'll be doing everything spontaneously or simultaneously, of Young modulus of a meter rule by principle of bending moments. Then determination of Young modulus of a meter rule So in this one, they gave me a table, and I'm lucky in that table I have readings. So they gave me a table of readings, then they have the load, or you say mass, in kg to be 0, 1, 2, 3. This is plenty. 4, 5, 6, 7, 8, 9. So I now have the L plus or minus. This plus or minus 0.01 means what? Error, should be changing. So load increasing. We'll talk about how all these things are gotten briefly. So they gave us this. So the only work you are doing in this practical with regards to the table is just to find the mean. It's just the mean they asked you to find. They didn't make room for what I'm thinking, but let's use this one. So then this person did the mean, and then you have 2.32, she got 2.36, 2.41. Okay, thank you. So, why I say let's have time to do this one as well is that this one they give us is looking quite very simple. So, when it has to do with determination of young modulus using bending moments, we will definitely be provided with mass as well. The mass we are using. Let's say this time, but wait, this thing I'm saying here, 1, 2, 3, 4, 5 in kg. Is it like 1 watt in kg? Is it 1 kg, 2 kg, 3? Is it what it means? Wow. Okay. Here, let's say I have 0.1 kg. 0.1 kg is the same thing as 100 grams, Chevy. Okay, let's say I have 0.2 here. Okay, and you know I don't have to be putting this kg. This place will do the job. Then I have 0.3, 0.4, 0.5. So let's say this is the initial length, the first length I'm checking out. Then let's say this one is L. We'll talk about it. Then let's say this is Y. Okay. So I'll start with these two before doing that so that I can use that space to write. Then after we'll now read that one. So please, this particular one, they did the whole work. But we know that young modulus practical is simply talking about us checking the stiffness or elasticity of the material. That's what young modulus is all about. The stiffness or plastic, or should I say the elasticity, the stiffness or the measure of the stiffness or elasticity of a material is known as young modulus. In fact, another way you can think of young modulus is simply when it has to do with materials, what you think of as friction in normal day-to-day life. Young modulus is friction when it has to do with materials. So an object resisting elasticity or resisting bending is what we know as young modulus. So if an object resists bending or resists being compressed, you call it young modulus. But physicists just define it so that you don't have to speak long grammar. They just define it as the measure of the stiffness or elasticity of a material. So if I know that that is young modulus, so in some books you see it as Y, in some you see it as E. The same thing. So if I know this, there's nothing much to stress on here because they've already given us the mass and they gave us the readings. That means how they did this practical is simply as they add they added no mass on that particular wire. They got that the readings, both since it's just normal, it's just this value that you have. They now added one, you said this is 1 kg. It's looking so hard to make. 1 kg is like what in gram? 1,000 shaving. So they now added 1,000 gram to that particular wire. Now they noticed as they added that wire, they took note of the increments. That is that increasing. You notice. Then when you remove that 1,000 gram, as you remove it, that particular wire is trying to go back to its measurements. That is to its normal state. You still measure that part. You still get that measurement. Check it. That is what they did for all these things you are seeing, plus or minus. So you put the load. When you put the load, that is the increasing. Then when you remove it, you still go and measure it. You put the load, you check the measurement. When you remove it, you still go back and measure it. So that is what they did here, and they got all these readings. Now, when it has to do with this one, I said I want to do the two together. Now, when I finish explaining this, we'll go back and solve the questions in that manual. Now, when it has to do with bending moment, or you say cantilever, when you hear cantilever, it's simply talking about any practical you do by extending a particular part, be it a bar or meter rule or a pole. So this particular practical is one that you do by maybe you are using your table or knife edge. You know the knife edge is something like this now. Maybe I can do this practical by using knife edge. Let's say I place my meter rule on top of this now. I can do this practical this way. There should be equal. I get the measurement from this end to this end. Let's say the measurement from the two centers is like 80 cm. I will get the measurement. Another way to do this practical is also if I come to my table, I place my meter rule, use G clamp to hold the meter rule firmly to this table. You know how your table is now from the other. Hold it firmly. So I will check that if this is 100 cm, that means, see, if this is 80 cm, that means that this part is like 10, should be 90. And this part should be like what? Because meter rule is 100 centimeters, just to remember. So if that is the case, for this one, if I have that from this end to this end is like that 80 cm. I can also do this practical. So whichever one we are using, whichever way we choose to. So why am I doing the two? Just in case we are doing this one, we've done something like this, but maybe you go into the exam or you see this presentation. You still don't panic. We'll do the two together. So when you've gotten this set up, you've placed your meter rule under your table, held by that clamp. That means 20 centimeter mark is all the way here. While on this one, 10 cm here, 10 cm here, 80 cm is here. The next thing you are going to be doing now is to check from the ground level. That is from the ground. You place another meter rule from the ground to measure the height from ground to this place. The same thing with when I do this one. From the ground level, let's say this is the ground level. I place my meter rule and check the measurement from ground to this place. Now, whatever measurement it gives me from ground to this place, whatever measurement this one gives me from ground to this place, that is my LO, initial length. That is the initial length. I will note it. And in this case, I'm going to be using 86 centimeter. Why am I using 86 centimeter? You know that most of these practicals, they have what we call standards. So let's say you do your own, maybe you measure 90, whatever, it's still okay, depending on the lecturer. But I'm using a standard that I've noted. So for most of the young modulus practical, even there are some things I will still give you. Like that young modulus, we normally have it that for ruler, it's always 0.5 times 10 raised to the power 9. We talked about it in the first class. So if I've noted this, let me use 0.8 cm, 0.86. This is in meter, Shebi. So please, I'm trying to convert my own to meter. If it's in cm, it will be just 86. So meter. Notice now, this one I already put it in kg, so I'm using SI unit here. Unlike this one. This one did half and half job. This one is in kg. This one is in cm. It's looking somehow now. Sure you see it. So that means if truly you need to check if this mass they gave here is in kg. And this one is in cm. One kind though. It's one kind though. because it should be everything in this SI unit. So notice that the particular initial length is the same. Please note how we do all these practicals, because we are not just preparing to fill manner, we are preparing you for the sake of the exam too. So when I've noted this thing is the same for all, what I will now start to do is, let's say now I've noted the measurements from ground to this place. I said it's 86. I noted this one, I said it's 86 centimeter, which is 0.86 meter. Now what I will do next, when I remove this meter rule, what I will now do is, if it's this setup I'm using, knife edge I'm using, I will come and on top of this meter rule, I'm cleaning the length because you now know the length. So I can do it, so you see what we're doing. I will come on top of this meter rule. I will place a mass. I'll place a mass on top of it. So let's say the mass I'm placing there is that 100 gram, which is 0.1 kg. When I place it on top of this, so remember that I'm removing this thing. This is meter rule, so you don't go and think it's Catholic something we are doing. So I now place my 100 gram mass there. And where am I placing it? I'm placing it at the center of gravity. The center of gravity of a meter rule is always around its 52 centimeter or 50 centimeter mark. Always at the center. Even normally, everything, center of gravity happens at the center of everything. It's different from center of mass, which varies when the object is not uniform. So if I've noted this, you notice that when you put this mass, this particular meter rule will tend to come down. Is it not true? It's just like you go now, you place the meter rule, you carry yourself and sit on top. It will break now. So young modulus there is simply saying your weight is too much. So let's say as I place this particular mass on top of this thing, and this small mass just break this meter rule, it simply means that the meter rule is very stiff. It's not flexible. You get the point? That means we say that the young modulus will be high. The higher the stiffness, the higher the young modulus. I've said it in the first class. And the lower the young modulus, the lower the stiffness. That means the higher the elasticity. So if that be the case, if I place 0.1 kg here, whatever measurement it gives me, as it goes down like this, as it goes down this way, I will come and note it. In fact, I'm supposed to have here L1 and L2. I'm supposed to have L1 and L2. That is, as I put this in and it depress, I will check the measurements, come and record it as L1. Then, when I come here and remove this mass, the minute I remove this mass, as it's going back, see when it comes down here, as I put it and it's coming down, I'll come and take the same place I place my meter rule from ground, get the measurement from here to here. I note it. Now, when I remove the mass, as I remove this mass, I will come back again, check the measurements. Whatever measurement is giving me, I note it. The same thing, I come and put this 0.2 on top of this. Whatever measurement it gives me, I note it. Then, when I remove that mass, still go back with my meter rule and check it. The same thing with here. When I come to this part of this meter rule that extended out, I will come and place mass. Let's say I measure from here to here, maybe 1 centimeter or any measurement at all. The examiner will tell you. Let's say I place my 0.1 meter here. Remember that this is using bending moment concept. I'm not trying to make it to oscillate, just what is bringing down. So I will say, from this ground level to this place, is that my LO, the initial. Now, when I put this thing here, notice that this thing will tend to come down a bit. Sure, you know. It will tend to come down a bit. So that's coming down. Whatever measurement it is, I'll still come back again, place my meter rule, measure the height from that place to that place. I will note it. That thing now that I see from here, as it brings it down, that measurement, I will note it as L1. Now, when I come and remove the mass, because I tie it with masking tape, when I remove that mass, as it's trying to go back up, once it stops shaking gently, I still carry my meter rule, measure it again. That becomes my LO2. So I note it. Why are we doing L1 and L2? So that at the end of the day, we take the average. So if I've noted this, The general rule of thumb is simply to remember that this y now, this y that I'm seeing, is the same thing as displacement. I can also call it S. It is simply the difference between these parts, that is the initial length and the displacement. So the difference between the initial length and the extensions, be it going down and be it increasing, that is what that y is talking about. So I can also say that y is simply, the y I have here, that is in meter, is simply LO minus LO1. Hope you know that these two things will give me an average, right? So that's why when I started, I just put only LO. So you've noted how to do this practical. Let's say I now have LOM. That is the average here. Okay. Now, if I have this, I want to believe we understand the concept of what we are doing here. But ask.
You are saying that L1 will be.
Right.
Using the down one, not the up one.
Okay.
Is it that L means the initial, that is now 0 point?
LO means,
LO
means before I put weights, check what is there.
will minus any other thing that you got as an.
LO on its own just means before you put weight, get the measurement.
Yes.
Is it this one you're talking about?
Yes, that that you're saying that is L1, LO plus. Is it LO plus L1?
I never said plus, it's minus. Look at what we are doing. Let me do it. Let me say what I said again. This thing is you imagining. Be where I am. Don't live where I am. I've not reached there. I said, if I place weight on top of this thing, it will definitely make this thing, whatever mass I put here, if I place mass, not weight here, it will make this thing to drop, like more like, let's say it's not coming a bit down, that kind of mind something. Now, when I remove it, when I remove that mass, it will tend to go back up. So I'm taking L1 to be when it's decreased, L2 to be when it's going back. By the time I finish those two setups, I come and add the 2. Divide it by 2 because it's 2 things. So that is for that one. But please see what I'm saying, that at the end of the day, that is the same thing you have here. Notice, that same thing you have in the practical manner that they gave you. When you see increase, it simply means when they have removed the weight. Sorry, when they have removed the weight as it's going back. Decrease, it simply means when they added weights. That's a better way to put it. So, as you put weight, it decreases. As you remove weight, it increases. By the time you finish it, you add it up, you divide by 2. So I'm just using the average in this case. You already know that you should do remove and add. So I'm just using the average to get where I'm going. Now, see what I'm now saying is that whatever you've done, the y is simply the distance from this place, that time you started, the initial, that indido that you have, minus everything you are doing with regards to it coming down. You are no longer checking it going back up. What you are just checking is the average, the average that you got. Just whatever you have here minus, minus the average. So if I've noted that, that is y. And we also say that whenever we are doing your modulus of bending moment, or see how we do this thing so that some people don't just assume. Let's say I have now, let's do it this way. I have LO1. Let's do it this way. LO1. Let's say I have LO2. Then let's say I now have LO min. Then I now have y. So that it will be easy for understanding, which is LO minus LO. Yes? Yes? Yes. And LO is just mean. So let me just call it LO here. Better. So this one is simply when it is decreasing. That is when it is decreasing, sorry, as I add weight. And this one is when it's going back, when it's increasing. Let's do it this way, so that it will be easier for you to understand. So what I'm now saying is, if I add this weight now, if I add this weight on any of these are two practicals that are the same, but just that the process is different. This one will include the two knife edge. So if I add this, let's say when I added these weights, that the L moved from, notice that it's 0.86 here, Shebi. So let's say it's decreased as I added that weight to 0.84. You get the point now? So like I added that 0.1 to it, and it made the length to go down to like 0.84 on that meter rule. I will come and note it here for decrease 0.84. Now let's say as I remove this thing, then I measure it is going back up again. I notice that it's around 0.83. I notice that it's around 0.85, sorry. No, because once you remove the weight, it should go back up, Chebi. It should increase in length. Thank God. You are there. So it's around 0.85 or 0.856, thereabouts, getting back to its original length because nothing much has been done. So let's say this is like 0.855, or which is, let me leave it this way. Now I do the same thing again. This practical is us trying to analyze it. I'll still teach you how to do this practical without you stressing on yourself with all this. Just know the formula. You go about your business. Now, if I know this, I will now say this plus this will give me something, Shebi. Divide it by 2. You should be having around 0.85. Is it? Do for me, let me see.
Sir, excuse. Does it mean that that the mass is affecting the length in each of
See now, see. Now. Give me your hand fan. Give me your hand fan. See what we are doing. See what we are doing. I keep this hand fan here. I keep this hand fan here. I get the measurements. I come and carry this phone and keep. What happened? With the forefather, no. Because I'm holding it, I'm using masking tape to hold it, Shebi. My hand is the masking tape. Because that is the same way. Don't worry, yeah? That is the same way you use your meter, your masking tape to hold the mass. So I hold it. Now notice that this thing has decreased. Is it not true? I'm not applying weight. It has decreased on you so because of the weight. Now when you remove this thing, it tends to go back up. So that time that it decreased, you use your meter rule again, measure the height. Measure it. Now when you remove this, you still use your meter rule, measure it. So what you are checking there is that Y, so that by the end of the day you are checking when I remove the weight, was he able to go back fully to its original position, or was there some slight adjustment in it being compressed? That is what young modulus is. So you will keep doing it with different weights. As you add, it's compressed, you check the weight. Now when you remove it, how did it go back? Did it go back to its original length fully, or did it remain small? So these are the things you will be doing until you finish checking it with the mass. You note everything down. So that is young modulus for you. So you can do it with anything. It's not must use meter rule. Every object has its young modulus. It has resistance to compression. So that is what young modulus is. If you try to squeeze a book or try to break a stick, does it break easily or not? That's young modulus, the resistance. That my friend answering call. Are you for today? Okay, yes, I've seen your face. I am. So if I've noted that, do for me this and this. What do you have? 845 divided by 2. 845. That is approximately 0.85. Shebi? So I can do the same thing. I can do the same thing and I will note all the values. I will note all the values. But see here, because we are not doing this practical, why I'm explaining it so you understand what I am talking about. If I actually want to do this thing by the way it should be, since I'm not doing the practical to ensure accuracy, what I will tell you to use if you did not do this practical to ensure accuracy is simply go to the formula for anything bending moment. Is simply y equals to kn. Y equals to kn, where k is equals to GLQ all over 4b. I'll use d now, dq, then e for young modulus. The first class, we treated this thing extensively in the first class, but that first class, I did not record it. That's the problem. So, GL cube all over 4BD cube, E for young modulus. So now you see that by the time you do it well, so please, what I'm saying is, neglect here. I used it for, we are assuming that we're inside the practical lab, but provided we are not in the practical lab, we don't need to be checking increment. Increment, decrement is something we can use manual to do. Once we find y, I will show you. Let me not clean it. I will show you how to use the math. Oh yeah, now see. I will now remember that if that is the case, y will now be. Remember I said y is displacement, Shebi? And this is the formula. So this will now be that y is equals to GL cube all over 4BD cube E times M. Do you get the point now? Yes. So you need to note. You now say where D is simply breadth, or you say width of diameter rule. While D is simply thickness or depth of diameter rule. While E is simply young modulus. And then L is simply the length of the meter rule you used for that practical. You remember that time we said from this end to this end, we said 80 Shebi, and then when we balance it on meter on knife edge, we said from here to here to be 80. So the length of the part of the lever, or you say length of cantilever. So you know I told you that once you are saying so instead of calling it length of meter rule use, we say length of cantilever. So we can simply have it in mind that anytime I'm talking about cantilever, it's simply any practical that I am doing by making adjustment of a particular part to be suspended while the other part is hanging. That's the idea of a cantilever. So I just say length of cantilever used, and which is 8 in this case. So I've noted all these things now. Anytime I'm doing young modulus of anything by doing bending moments, this is my formula. I noticed in your practical they did not put this L cube there. So we use the one they gave you. But just note it. Anyone they give you, use it. But have it in mind, you learn the standard then. Use the ones given to you. There are some adjustments made that makes you have that one that you have. So if I've noted this now, I can now solve for K. I can solve for K now. Sure you know. Yes. So I can simply say, so please, remember this thing is inside your notebook. Inside your manual. Yes. You can copy it into your notebook. Why I made this diagram for this from your manual is because I want it to be on the video so that those of you that normally come, maybe by January, I told you the number will be much. So as they are coming, they just this one, I just say the video, the link. You guys see it there. So if I know that, I will say that G is 9.81. L is 80 cm now, which is equal to 0.0. This is divided by what? 0.8, Shemi? In meter. Thank you. I know we've taught dimension, but I hardly want to be doing that thing again, going back to do dimension. Then B, please, write it for me. I even showed you how we do this thing in the first practical. You determine the length of your meter rule and the breadth using vernier caliper. And that vernier caliper, we did it how to get it. We even did the standard error and everything in the first class. So today's one is to solve questions. It's not to discover things again. So we said that the breadth is gotten to be 2.5 cm. In most cases, you get it to be 2.66, whatever it is. But it's around that range. So this is going to be 0. What? 0.25. Now be participating. It's not the man be writing. You be copying. Be participating in this class. Now the depth, the D, we got it that day to be 0.5 cm, Shebi? Which is going to be 0. In meter, Shebi? Don't worry. As you are not participating, I'll just write one thing there. Be copying it. No, that's this young modulus we use that something. Now, this one you got 0.5, Shebi, which is this. For young modulus, we normally say that in physics we have range for young modulus of a meter rule. You will see things like 0.37 to Shebi 3.35 times 10 raised to power 9 Newton per meter squared. So, but in this practical, we are considering young modulus to be 0.5 times 10 raised to power 9 Newton per meter squared. Hope you know why this young modulus is stress over strain now. Which will definitely give you force over here. So please, this is what we are using. Don't question it. It's a standard. It's already there, just the way you have 9.81. So we get this. So if we know this, what we do now is to find K. Substitute all these values for the K we have. So if I substitute, I'm going to be having K to be equals to 9.81 times 0.8 raised to power 3 all over 4, Please, make sure, okay, make sure that we convert them properly. 0.25, Shebi, then 0.25 raised to power 3, right? Then the E is now 0 times 10 raised to power 9, Shebi. So please, there are some constants you must know. Like when we start doing gravitation, like I posted the video yesterday, you will come to know that Earth has a radius of 6,400 kilometers. Shebi, you saw the video. Some of you don't use your listening to watch. You will come to know that the radius of the sun is 1.5. Yes, 1.5 times 10 raised to power 11, yes. So you know all these things. You come to know that mass of the earth is 6.0 times 10 raised to power 24, thereabout. So all these constants you must know it because you don't expect them to always put it there. How do you know it? By knowing how to make each one subject of formula. When you make subject of formula, substitute. For example, all those things I'm calling now, like radius and the rest. Once you make radius subject of formula from that Newton's equation, equate it to any of those force, energy, you will get your value. So go and watch that video, very important. For your punch for me, this thing now, what do you have? Ask. He said? That is what I said, that in the manual, in your manual, the formula they gave you, they did not include this. That what we will use when we are solving that your own. What we are doing is bending moments of meter rule. The one you have is for wire. We said they did not include it, but when we are solving, we use the equation given to you. So the examiner determines what you do. So if an examiner wants, if normally you plot m over t squared. If the person wants, the person will come and tell you plot extension and whatever. You still do it. So punch for me. But what I'm giving you is a standard you should know. Punch for me. 9.81. Then he made 0.8 raised to the power 3. Then you times it. Then you do the division. What do you have for everything? Always do this thing separate before meeting up. Sometimes your ruler might be misbehaving. Your calculator might be misbehaving. A punch, I will give you one thing, you go and write it inside the exam. And do you know one good thing about lecturers? Your mistakes, they've made it. So as you make that mistake and look, the A option is that your answer. You shade it. Or your punch, what do you have? 0.80. Eh? 0.8036. 4 decimal place, my friends. Oh, yeah, now see something. This is K, Shebi. Is it not? This is K. But remember that what we want to find is Y. Shall you remember? And y, we said that y is given by, for anything bending moments or cantilever bending moment, principle of bending moment. This is our formula. When we get to oscillation of cantilever, I'll show you how the formula is. So if I know this, y will now be equals to 0.8036. Now notice something. For y1, sure you know that here is y1. The first one. This one will be y2. Is it not true? This will be y3. So for y1, you will have m1. And m1 there is 0. What? 0.1. So do for me. This thing times 0.1, what do you have? Huh? 0.08. 0.0. Hey. Okun Manon was science students. Eh? Some even have medical students to it. Talk like medical students. 0.08036. Okay, 0.08. 0.36. No, I don't need it. I need it in 2 decimal place. Now for the 0.2 parts, this is 0.2. 0.8036 times 0.2. I have punch on 0.1. 0.16. Times 0.3. This third one. 0.24. How I wish you are following me. Are you following me? So 0.24. Then times 0.4. 0.32. Okay, times 0.5. 0.40. Okay, this one is 0.40. I will not be doing the graph plotting because I've treated how to plot graph. So now that I know this, I've gotten my y. I've gotten my y. So what it means is that if you did not do the practical, what you just need is simply come to the lab as they are doing what they are doing. Get the measurement from the ground to where they mounted that meter rule. Once you get the measurement, you go, go and sleep. Then you wake up, bath, you now come and remember all these things now. That the breadth, vernier, it's not maybe. If you notice, the meter rule is always looking the same. That meter rule. So it's not something like you come and see that the vernier scale reading here is maybe 2.5, then tomorrow you wake up, it's 4.5. No, it will always be in this range. So 2.5, 2.66, 2.6, thereabouts. So it will always be in this range. The same thing with the depth. So if you know all these things, I remember what I said about this. It's just like if I remember, there are some constants I don't have to ever forget. If I want to say Avogadro, I remember 6.022 times 10. I know that I'm raising it to 22, Shebin, or is it 23? So there are constants that you must have upstairs. So this is one of them. This one is one of them. In an aqua, don't get too much. Okay, open my hand now. So, copy, I'm coming. And that day went through that is very over 2. That is means to. This thing is like, Sherry, you can see what we are doing. Okay. This thing is like to, it's more like a range to. Yeah? That's what I'm saying. Okay, maybe that here, because here there's reflection of light. No, I am considerate. I want to be sure that everybody's following me. Oh yeah, so we've gotten that one, we've gotten the displacement, which is y. Now let's get L. Now these two will not do manual for it. Provided he did not do the practical. How do I do this now? I'll say, I can clean this, you have it now. I need to clean. What are you waiting for now? So notice that from y to be equals to LO, that is the initial length minus the extension, this will be the sentence that saying that L is equals to y minus LO, because this will cross over, shall we? Wait, if this one cross over, it becomes positive, right? That means that it will be LO minus y. Share? Going here, plus, going here, negative, okay? So I have that L will be equals to, so that means that L will be equals to, L will be equals to LO minus y. How I wish you are following me. Are you following? You are not following? Hell, idiot. Always eat before coming. You think it's a joke. Eat so that your problems will reduce. See, we've not done anything. The only thing we've done is that we used an equation. See, nothing special. An equation to take note of. Equation of the practical. For anything bending moment, I said equation of the practical. So, from here, we said I K is a constant which is equals to this. What did I do that is special? I just came, used all the constants, substituted it into the equation, and I got K. How did I get constant for E? I said it is there, it is a constant that E is 0, that is E falls within the range of 0.37 to 3.5 times 10 to the power 9. Myself now, I now chose a standard constant which is 0.5 times 10. If you don't want to use this one and you want to use 0.37 times 10 to the power 9, you are allowed. So I just chose a constant that falls within that range. That is just what I did. So it's just like me now, I come, they tell me gravity, acceleration due to gravity is 9.81. Then you ask me, how did you get it to be 9.81? You will not tell me if I'm an astronomer that goes to the equator to go and measure. Are you aware that they measured all those things? Then they got that is around 9.8, 9.7 thereabouts. Before then doing the math to show us how they came about it. So it's the same principle I'm giving you here. So if you now need us to be showing you how we derive, that is where I now go and post YouTube video inside the group. You check how we derived it. I've done that of simple pendulum. So anyone that will do, you still need how to derive it. It's not what we do here. I just post the video to the group. That our paid students group. You use it and watch how we derive it. So if I know that, I now said, come back to y. Remember that y is simply displacement from the initial position, then downwards. That is getting the measurement before adding the mass, then the decrease. That is the extension, which is more like the fall in the length. So if I get it, and I say, make it L so that the formula I have this. So all I need to do is to now say, I already have LO. And then I have Y. What I will just do is to simply say, in this first one, I will be doing LO minus Y, which is 0.86 minus 0.08. This is how to go about this practical if you did not do it. And you will see that if somebody was in the lab to do this, that your answer will be even more correct than that person. Unless the person really took his time to do the practical well. Because this is from the formula. So, do for me this minus this. 0. Oh yeah, do for me this minus this. 0.7. Do for me this minus this. 0.62. This minus this. This minus this. So what am I saying? All those things we started with is to show you how the practical is done. But if you did not do the practical, because if you notice, even inside the exam hall, you are not doing practical. It's just for them to give you questions, right? Procedures. You are to conduct a practical that did this, and this one was done. This one was done. How do you do this? Look at table of values, complete it. So having this now goes a long way. So if I have noted this, see what I'm now going to be doing. Between these two now, this one is increased, going back now, after I add weights. Why this one is simply what? Decrease. When I added weight, it's coming down, right? Now notice something. Here is 0.78. Is it not true? This, Shebi, remember that this thing is more like the average of these two. So what I will simply do is simply to say, let's say that this thing here, going back, then guys, going back, let's say this is around 0.78 on coming down. Let's say on going back, this is around 0.80. If I divide, does it give me the same thing? No. Hey.
Use 7.
What do for me? Shall you see the man we are doing now? Because we did not do the practical now, so we need to put it in a way that as we are checking, we are now showing them this increment and decrement. By the time we do it and divide by 2, it should tally with this thing. That's what we mean there.
This one is down.
This one is when it's down, should be going down. No, minus means decrease now. As you put the weight, it's coming down.
This one should be lesser.
Which means this one should be lesser now. No, this one should be lesser. This one should be more because it's going back up.
Then this one should be 7.
Which okay.
7, 8.
Okay, 7, 7. Okay.
Okay, 7, 9.
Okay, wait. 7. Wait, if I use 7, 8 and 7, 9, uncle. Okay, 7, 7.
And 7, 9. Yes, it will give you 0.78.
Oh yeah, well, do for me. If you come here now, I will have, let's say I have here 0.69 and then 6, 7, then 0.69. Is it the same thing? Well, Pia, what do you have? What's the right thing I'm doing?
7, 1.
7, 1 and
6, 9, 7, 1.
you are doing my man more than me now. It's all right. So here I am having
0.61 and 0.63.
okay. So it will give you this thing, right? When you divide by 2. Okay. Then go over here.
0.53 and 0.55.
Okay, 0.53.
And 0.55.
Okay. Some people don't even understand what is going on. Hey. That's why they have BMW and Passat. Yes. You make sure that your engine is always active. So what we are doing here is what we call manipulation. You manu it. Because we know that these two, when we divide it by 2, it equals to this thing we've got. And you know we did not do this practical now. So we are trying to do it in a way that at the end of the day, the decreased part, the part that shows that as we put the thing, it drops, is lesser than the other part that when we remove it is going up, which is this plus that I'm putting here. So by the time we now do the 2 sum, divide by 2 should give me this. That's what we are just doing. So we are doing a manual here, adding, manipulating the values. But the other ones, we did it well using the practical equation. So what do you have for this one?
0.45 and 0.47.
Sharp. Very sharp. So when I have this, please, when I'm doing this, is I want to make sure that we touch all the practicals possibly. So that, you know, if you notice, we've done your modulus, done viscosity, done coefficient of friction, using Pauline's formula and using Stokes' law. So today I am teaching you wire, young modulus of wire material, teaching you bending moment. Then I'm going to teach you oscillation of cantilever. So this thing you see now, like 3 different practicals you see observing here. So you learn it. So even as we progress, when we come back January, we'll still continue. But what we are looking at, if we notice that your lecturers are still active and coming, tutorials will continue. Because you know why? You know why? The reason we wanted to go on break is that students on Saturday were not in class. Most of them went home. Now we now take it that by this week lecturers will not be coming. And I know that by at most Tuesday, Wednesday, none of them will come again. So if they come here tomorrow, we'll do class tomorrow. That means that we are not going on break on Wednesday. Do you understand? No, now see what I mean? See, but you understand my point? Let's leave my point and focus. Can I continue? So, see, we've gotten this. Now, please, if we go back, let's then go back to your table. Let's go back to your table. Can I claim? If you go back to that your table, the first question on your table, I'm not plotting graph. I'm not plotting graph because I've taught you how to plot graph. But please remember that inside the exam hall, once you have your graph table, that's the first thing you need to always do is to write your dates. Very important. You've written the Chevi, then the next thing is to write the title of your graph. A graph of...
On the graph.
Above now, you are your graph. If you know that part, I have space for writing something. So a graph of, let's say you have mass against extension. You don't come here and write, see what some people normally do. Graph of y against x. Eh? You are joking. Eh? Just playing. Please. This thing should carry the thing you are doing. So it should be a graph of mass, if it's mass you are using. And this mass we have its unit kg against, let's say it's extension, against extension. And extension should be in meter, should be? You write it. Very important. Now, Shebi says I've written this and I've written this. And I do whatever, I find my skills. I've taught you how to find skills. After finding my skills, I'll still come back here. This place that I wrote it, and I write my skill. Yes. So you remember how we normally do it. Y is to whatever. X is to whatever. That is the vertical axis is to whatever. X axis is to whatever. So it's important because some people, their own is if they go inside the exam hall, they just carry manual, staff solving. It's of no title, no dates. No skill. When marking should just kill himself looking at your manual. So please remember to do this. So I don't have to plot graph again. I've taught you how to. If you need how to plot graph, how to identify skill, just chat me up. Just tell me, send me the video. Where is that girl that met me last class? She was not in class when we did graphing. So you just chat me up, tell me to send you the class on that. I'll send it to you. Now please watch. Read the first question inside that particular young modulus of wire.
Derive the mass.
Derive the mass. And they read everything.
As a function of the linear reading, I, original length, and basis of wire, R, and young modulus.
Okay, come again. See, they said derive the mass. You mean?
As a function of the linear reading, I, original length,
Original length, then I, okay, they use linear reading to be I.
Yes.
Okay.
Radius of wire, R.
Okay.
Young modulus, E.
Okay, but please, that linear reading part, check for me well. Is it the part where they wrote plus or minus?
Yes,
That is all these things here. Should we? All these things. Are you sure it's I that thing is supposed to be? Or small letter L? Is it not small letter? Huh? Come follow me. Welcome, my friend. Thank you. So, linear reading. I want to use that in a small letter. Yeah. Because notice something, now notice something. Is it not in cm? Chevy? Cm is the unit of length now. That is meter. Meter is this SI unit. So I'm using that in a small letter L, not I. I'm using it as small letter L. That's what I want to use it as. I use it as small letter L. So that thing is supposed to be small letter L because if you check, there is nothing of I. I has to do with electric current. As far as physics is concerned.
It's looking like one.
It's looking like 1. It can't even be 1.
It cannot be a number.
It can't even be 1 because there is no dimension. And you know that all these quantities, mass, length, all those things, when I have their initials, there means dimension. So there's no dimension that has number to it, or there is a number. So it's small letter L. So if I'm doing this now, I will have room for, first of all, young modulus is equals to, okay, first let's start with stress over strain, shall we? Okay, and this is force over area, shall we? All over strain, uncle. Extension over length. Please, how I want you to always remember anything that has to do with this over. The main thing is always at the denominator. The one that comes there to change the state of that thing stays at the numerator. For example, you have to have a length before you can extend something. You have to have an area before force can be applied. So check it with everything you know, like density. You have to have a volume before you are checking the mass or the quantity of that thing that is in. Like you have to now compare the quantities that can be in that volume. Because I told you that density talks about how much of a quantity of a particular substance in a given volume. So, and it's comparable. So if I know this, and I have this. So if you check this very well, this is the sentence, this is mg, Shebin. And area is the sentence as pi r squared. Shebin? Yes. Do you know that this is the sentence saying pi d over 2 square? Shebin? Yes. But let's use this one so that we don't complicate things. So pi r squared. Then all over. This is E. Let me represent this with X. Extension from here to here. Displacing it. So, or let me represent this. Since they gave me small letter L here, let me represent this one with small letter L. And then this one with capital letter L. Are you saying it? So if I know this, now notice, this is now the sentence as having mg over pi r squared divided by L over L, which is the sentence saying mg over pi r squared times L over L. So that's, this will not be mg all over pi r squared L, then and I have this like this. Now, if you watch, if you watch that equation given to you, in the second part is looking like something like this. That second one given to you. So what they did there is that normally whenever we do young modulus, We normally cancel L with L, sure you know, but they left it. Let me look at that your manual again. That is the second part. So they did GL over pi r squared, then you now have multiplied by the slope in that place. So we'll now show you what it means. So this is how we are leaving it. So as we progress, now you will check from that particular question. What did they ask you to plot? What did they ask you in that particular manual to plot as your graph?
Graph of mass against
Graph of mass, Shebi? Against linear reading. That is the small L. Use this thing as L. Use it as L. Don't use it as 1. Don't use it as I. Use it as L. So if I know this, that means that CO, I can clean this side now. So the only thing remaining once we finish this question is now to do when it's having to do with cantilever oscillation. Every one of you owe me A. Imagine a serious A. The first result you will see after first semester exam is physics practical. Like, let's say you write it this week. After 2 weeks, the result is out. Other courses will be waiting for you to enter second semester 200 level before you see the result. Practical does not waste time. You just see it live. It's because of the camera. There are some things I'm supposed to tell you. But let's leave it. I cannot off it. No, we will not pause it. We will talk about it. Don't worry. See, you don't see that E is equals to M. I can have this to be over L. Then I have G L over pi R squared. Do you agree with me that this thing is the same thing with this? See? And since they asked me to plot a graph of mass against linear reading, so where L, you can say where L, this small L is linear reading. That means that slope simply means y-axis. Anytime you hear this against this, A against B means A is vertical axis, Y, B is x-axis. Sure, you know. So if that be the case, this is the ordinate, this is the abscissa. So this will now be E equals to slope, then GL over pi r squared. So what they did in this thing now, this practical is simply a simple practical. It involves just Young modulus. Just a simple practical. What this practical involves is just as it goes down, it extends, get it, you remove, you check. So it's not really all about, like, it's not fully about bending moment. Do you remember that bending moment has to do with when I place that particular thing? It has to maybe make it come down and make it come up. Is it not true? So, but this one, for that wire is a simple practical in the sense that it simply deals with, as I put that load on that wire, if it makes it drop, check. Then remove it. As it goes back, check. So it's simply talking about, this one now, this practical is simply talking about extension and length. You see it? So whenever that practical, you're determining Young modulus. Whenever you're determining Young modulus, by doing that, your extension and the length, it simply means that you are still on that, what Young modulus is all about. That is stress and strain. You get the point now? So please, that is why this practical is not having that our GL cube over 4B B cube E. You can take the because when we get to this one has its own equation as well. So note all these things. When it has to do with, you can just go and write it somewhere in your notebook. When it has to do with wire, or stress and strain, or maybe just extension, and coming back to its length. You are just using this thing, and it's very simple. It's just the normal thing. So if I know this now, I can also come back. Okay, I can use this to solve. That is anything I get as my slope in the graph. Anything I get as my slope in the graph, times with G. The length was given in that manner. They gave you 130 thereabouts. Then the arrow will be gotten from the diameter you have there. If you divide that diameter by 2, you put this value. But see what I'm trying to say. They can give you a question. Inside that exam hall, they tell you, show the equation of the simple, show the equation of the young modulus to, or should I say, your practical to be that of a straight line equation. So what I will do in that case is to first of all remember that from here, I can make m. Remember the equation of a straight line is simply y equals to mx plus c. And this is the same thing as saying y equals to mx. And it's also the same thing as saying y equals to c. If you remember when we did dimensional analysis, I told you that anytime something and something is plus, it means that they are the same thing. So if I know that, it will not mean that from here, I will make y. So trying to make y is the part. Please see from here. Y is the part we plot on the vertical axis. And x is the part we plot on the horizontal axis. So if that be the case, how do I make this thing to have this L to be on the x-axis and this M to be on the y-axis? So how I will do that is to simply say E equals to mgl over L by R squared. So that by the time I do this, this is the same thing as saying E by R squared L, small l, is equals to mgl, should be? So, yes, very simple. So I now divide both sides by gl. Divide by gl. So that this will cancel this. So m now will be equals to E pi R squared all over gl times small l. That means that everything here stands for my slope. Are you seeing it? That is m. And everything here stands as the x. And this one stands as what? Y. You get the point now? Which means that likely, what this thing means is that likely, when you now get your intercept, likely any equation that falls this way, likely your intercept will be 0. But if it's not 0, whatever you get as your intercept, and you know that intercept on your graph is simply, if I have this thing now, if it comes and cuts here, Shebi, that means I will now come and do plus that c, whatever value I have there, is that my intercept. But if there is nothing here, likely whenever you have this kind of equation that does not make room for the intercept, that means likely your intercept will be on the x-axis. It doesn't mean that you shouldn't plot your graph. If you've plotted, whatever value it gives you, that is what you are now writing here. So we don't make room for this until you plot your graph if it's not given. So this is what you have. This L stands for x-axis. This M stands for y-axis. And this thing that is here is now the M for the slope. M here means slope. M here means slope. C here means intercept. Please, if today is your first time, sometimes we post video inside that our short age general group for paid students. Some of you will just leave it and pass. But if it's TikTok, then you can watch. But once it's physics, it's not for you. Please, take it serious. You'll see that every of the class I post here is something that if you watch, it will help you add to your thinking when you're thinking over it. So please, if for example you go inside the exam hall and they tell you to represent this as the equation of a straight line, that is what they expect you to do. You don't understand? Which one? The slope, yes, man. This is the slope m over n, Shebi. Oh. Zachariah 1 came mad. Can I claim? Okay, how we derive from here to here? Do you understand it? Yes. Okay. No problem, there's no problem. Aboki we say is ba yawa. Should we? Oh, see what I'm saying. If I have E equals to M over L, why though? Your hand fan, is it not your own? Why though? You're doing it. Hell! Obodo Igbo. Why don't you need projector, Shelby? But it's because you don't allow me to put you where I like. Where I like is you staying here. Eh? Facing the board. Allow me to be putting you where I like. You will start liking it soon. Yeah? Ngwanam. So see, this is M over L. And I have GL pi r square. See what I'm saying? See, if I have this to be y equals to mx plus c. Let's say I ignore this plus c because in this one I don't have the intercept. Now, if I want you to get me the slope now, Shebi, the slope is always the y-axis and the x-axis. Shebi, I have do it for me from here now. I'll divide both sides by what? Is it m or x, Shebi? So that then I have y over x to be equal to what? M, which is what? Slope. Do you agree? This is, you understand this one? And remember that m over L that is here. This one will take part of y. This one will take the role of x, Shebi. How do I make it so that before this thing got to this stage, since it's these two things I'm using as my slope, how do I make it before I got to this stage to have this kind of expression? So how do I make this to become y here? And how do I make this one to become x here? So how do I make it so that m will be y and L will be like x, then I will now have the slope. Sorry, then yes, I will now have the slope equation. That is that side that is facing it. So the only way to do it is simply try to make m subject of the formula. So if I make m subject of the formula, it simply means that everything here will multiply this so that I now have e pi r square L equals to mg capital L. This one is small l. Or you call it extension, or you call it linearity. So if I do this properly, by the time you make this subject of formula, you now see that this will divide this. That is GL, GL. You get the point now? So if it divides, you now see that I now have M this way equals to E I square, shall we? Over G, and this is capital L, right? Now times this small l. You see it? Very simple. Or tomorrow, can I see? So times this small l. And notice that by the time you check it, it simply means that what you have here is functioning as m. This one is functioning as x. And this one is functioning as y. That's the point. So when they tell you ever to express what you have as an equation of straight line, this is what they expect from you. So please, let's calculate this young modulus from that your this thing. So please, they gave you 130 cm, right? Convert it to meter.
1.
Is it 1.3? 1.3 meter. Always convert SI units. Do you know why? If you don't remember to convert to SI units, you might forget that your G is always in meter already, the SI units. So when you go and solve, you put yourself in trouble. So always try to convert.
You never convert the other one.
Yeah, you convert everything to SI units. So now E will now be equals to C. Remember that, did they give me mass? They did not give me mass, Shebi. Because the mass I have is the mass of each thing I did there. Unless I want to use, and this one is not even practical, this thing I'm using. Like, it's not like maybe I have to use ruler, meter rule. So that means, please, see when you're doing this, whatever you get as your slope, you open it with a slope, beginning of the day. Then, my G, and I'll come here and do something here now. I'll do something to this thing. I'm coming to this thing. We'll get the mass here. Let's first get the mass. Hello? Because it's easy for us now. I just hope you are still here. I just hope you are still here. Okay, ask. Will you write? Yes, that you will show the unit of that slope. For example, if the slope, for example, this is mass and Shebi, is it not true? And this is in meter. So this is going to be in kilogram per meter. So you must show the units in SI units. So even if you show it in the unit you are given in the practical, you still come back and show it in that SI unit. Very important. Please, all those things they gave you in centimeter, convert to the SI unit. But if you don't want to use it in SI unit, that means the kilogram, you have to convert it back to gram. That's what it means. So if that be the case, let's find the mass here. M will be equals to E is 0.5 times 10 raised to the power 9. Should you remember? If you want to use 0.33, no problem. Then times 22 over 7 raised to the power 2. Should be? They gave us diameter. The diameter they gave to us is 4 point what?
4.0 plus or minus 0.2.
4 plus or minus 0.2. Leave that plus or minus 0.2. Nothing means the changing for error. When calculating times 10 raised to the power minus 4. That's plus or minus anything you normally see is when you are calculating error, you use it. When you are solving, don't use it. In CM, wow, okay. In CM, that means to convert this to meter first is what? That is divided by 10 raised to the power by 10 raised to the power 2. Shall we? Which is the same thing as saying 4. Shall we? So to convert, this is a meter now. Hope you know what we are doing. Pay attention. There is a level of attention you pay, you will be following. If it's not entering, you open eyes well. So you see it well. See, I said, this thing now is in centimeter. I cannot use it in centimeter. I want to convert it to meter. How do you convert to meter from centimeter? You divide by 100. Is it not true? So if I divide this by 100, it's the same thing as saying 10 raised to the power 2. So if this is 10 raised to the power 2, indices, go and watch my video on 9 laws of indices. I'll post it this night. Indices says that this thing now is the same thing as saying 4.0 times 10 raised to the power minus 4 times 1 over 10 raised to the power 2. Indices is saying that anytime the numerator of anything is 1, that thing is having negative power. That means that this thing is the same thing as saying 4.0 times 10 raised to the power minus 4 times 10 raised to the power minus. He's saying plus 1 is your numerator. The denominator is having a negative power. So that is what I've done here. And since the bases are the same, add the powers. So if I put plus here, it will be the same as minus 4 plus minus 2, which is 4.0 times 10 raised to the power minus 6. So I've converted it to meter. But remember that this thing is diameter, Shebi? So to convert to its radius now is what? Divide by 2, Shebi? So you then get what? 2.2 like this, Shebi? All over. Now divided by G is 9 point what? 81. Do you still remember? Yes. And the length of the wire given to us. Shebi, I told you at this junction, start using 9.81 as G so that it will master you. So then the length is 1.3 in meter. Oh, yeah? Okay, it's R. No, sorry. God bless. Victoria, you're always saying things. Oh, yeah, punch. Punch, what do you have? Do you know my happiness? Eh? Those of you that will come to disturb me for this class, the video is loading. Eh? You watch, rewatch. Oh, yeah, punch. What's the mass? Punch, what's your answer? Punch, what's your answer? Imagine, he says, 4.92 times 10. Okay, like this. I know it's in kilogram, which means that this is the center as a mass is equals to 5 times 10, approximately 5 times 10 raised to the power minus 4 kilogram. So, if I have this, for me to now find my young modulus, what I can now do at this junction, but I still don't know this length of reading, length of the reading, linear reading. Let me see that workbook. If there's anything they gave me there. Did they give us anything generally for that linear reading? Let me see. I'm trying to see if we can get. It's a constant. Yes, now like we use that constant, then we want to now find it using that our slope. You know that you will get your slope now? Yes. Okay. They didn't give us the small l. See, that means, see what I'm trying to do. Hope you remember, that by the time you do this thing now, this is going to be the sentence saying, do you know that this is the sentence saying m over l is equal to this side? Sure, you know. If I have this l here now, if I say divide both sides by this l, it's not m over l equals to this your slope now, which is the sentence saying the slope you will have from your graph notebook should be equals to what we've done here. That's normal thing we normally do, that slope part from the graph, whatever we get as our slope should be equal or close to what we have on the right hand side. That is what we are trying to do here, the small l here. So we've gotten m, but they did not give us l, which means that everything is still trying to take us back to us having to plot the graph. So when you plot your graph, whatever you get as your slope, for those of you, have you plotted your graph? What did you get as your slope?
25, 22, 26.
Okay, some persons are getting 26. And notice that the reason is that you used values in centimeter, not meter.
Yes, you not convert it.
You see, it's not you not convert it. It's not you not convert it. First of all, this thing now that is here, did you convert to meter when you did your own?
Yes. So,
Guys, this 4.0 whatever.
you're not using it to plot graph now.
We're not using to plot.
Okay, you did not. I'm asking you, did you convert this one to meter in your book?
No.
You did not. Okay, the values on your table. And that is the kg. Did you take it back to gram?
No.
And if I'm to use SI unit, I cannot use it half.
It's not affect.
It will affect now. I have centimeter, I have kilogram. It's not possible now. I have centimeter, I have kilogram. Kilogram is an SI unit. Meter is an SI unit.
So I will use just this is there. If I finish, I should just come and.
You can't do it that way. Reason that, assuming what you are using, the two things you are using are entirely of SI units. That's where you can now say, if I finish, I come and convert it back to the SI units. But here you are using 1 centimeter. You are using the one that is in centimeter. Using that is centimeter that is not in SI unit. Then you are not using the one that is not in SI unit. So it's not possible that you finish and you say you want to convert it. So what you do is entirely you can convert the whole kilogram to gram. Use it with your centimeter. Then when you finish, whatever answer you have, you can now take it back to SI units, which is 9 kilogram and meter. That is, convert it then. So, but provided you use this half and half, your answer must be wrong. Yes, it must be wrong. So please, you use the SI units, very important. So, if you do this thing very well, your slope should be, because check what we did now gave us around what, Seth? 5 times something, shall we? So that means by the time you do this thing properly, your answer should be in this range. That is, the answer you have for your slope should be in this range, because this thing is more like the same thing as our slope, but we've plotted it using the formula. So by the time you finish it, that is why some of you are getting 2.5, almost half of it. So do it well. Do it well. So do it well. You are wrong. You are the one that is wrong. Me, I am correct. I am very sure that I am correct. Fire, give me the next question. Then we can go to determination using
Calculate the error
calculate the error.
and source of the error.
Did they say standard error?
No.
They just said error.
Error is E.
Okay, please. Whenever they say error, attention should be paid to. Is this, did they say calculate the standard error? Or did they say calculate the error? Because if they say standard error, the method we are to use now is not the one we are supposed to use. But since they say just error, we use the method we used in our last class when it's just error. So I want to clean. R, that is reduced from the diameter given. 4 points. No. Okay, the 1.3. This one is that length given, not arrow. That length given, they give me length of 130 cm. So that 130 cm converted to meter is 1.3. Why the arrow, the diameter, converted to meter, then divided by 2. So that means this is a thank God for you class. This class is a thank God for you class. Because some persons already did that thing with cm and kilogram. It's very wrong. Very, very wrong. Alright, now see. If I'm to find error, they did not say standard error, I'm to find error. What I will simply do is to remember, they said error in young modulus. The formula, the things I have is simply mass over L, then G L over pi r squared. Now please notice, this thing is a constant. I did not make any measurements on this. So I'm going to be having E first of all. This thing is your slope, Shebi.
Yeah.
Error in slope, change in slope. Do you still remember it?
No.
It's the same thing as error in slope. We'll come to that. So I will say my slope, this side. Then G is constant. Okay. Then I have, yes, G is a constant, which means I don't have need for it, Shebi. So I have my L. This one is also a constant, sure you know.
Radius is a constant.
This is pi, now pi. They gave me radius for the diameter, Shebi. And that diameter was in linear scale. Is it not true? These two, they are constants. So please notice that we are outlining everything that we have. Then divided by r squared. So is error we are calculating, not standard error. Thank you very much for pointing that radius out for us. So if I've gotten this, it simply means that what I'll be doing here, I can do this in 2 ways, and it's easy. Please identify your slope. You will simply now use change, that is change in E over E will be equals to change in slope over slope plus, notice here, this is L, Shebi. Change in L over L plus, this is 2, Shebi. What will I do? That means you plant it. So please, this is how we do it. This is the equation. Then we are going to do it together. We are going to do it together because I don't like class half and half. So please, we've done determination of young modulus of material of a wire. Then we've done determination of young modulus of a meter rule by principle of bending moment. So the one remaining, which we will do today as well, is by oscillation of cantilever. So when people are taking their life serious, some people are imagining why some people are very serious. Just be playing. Okay. See, my E, what's my E? Check, 0. times what? Times power 9, Shebi. And this is the young modulus. Young modulus, Shebi. Then the change in E, I don't know it. Hope you know that that's what they are asking me to find. Shebi, you remember that they're asking me to find error in young modulus. So I don't know it. Error means changing. I don't know that one. So I'll leave it this way. Now, equals to. My slope is what? I got it, I know. You, it's up to you now to go and get your own to be close to like our own. I asked. Is what? What I got from the young modulus. That is doing this thing now. Yes, now. See, the 0.5 times 10 raised to the power 9 that I'm using is that standard. We gave you a range. I'm picking this. Now, when you do your own, that is when you've got to your slope and do whatever you've done, it should still fall within that our range. So it's not far. That is why I'm picking this one. So if you get your slope that should tally, not too far, and put it and solve, it should give you something within that range. I already gave you a range. So now, please, my slope, I have 5 times 10 raised to the power minus 4. No, Shebi? Check, or is it?
Correct. But you know divide this.
Okay, yes, we did M over L equals to that.
Not divide this by.
So let me do this. This is the sentence I said over L. Sure, you know.
When
You
you
said
divided it,
right, it will not be in kg, it will be in kg per meter. Divided what?
you know, when we go to actually
See, let me tell you, there's something they call control your thoughts. Listen. When you think that outburst, do it on your notebook. If it's not really sure, you not give us. Because we cannot come and divide anything here. This is not that one we are talking about. That one you're talking about is that time of degree of accuracy. That degree of accuracy, here they do plus or minus. But notice in this work, they gave it to us. So we don't have to divide anything here. Our slope is here. That is this thing. Now, change in slope will be that thing we get from, that time we normally do error in slope or change in S. Will not be equals to 4W over any R. Do you still remember? So let me just write it. 4W over any R. Whatever it gives me is what I'm putting here. And I will show you how to get it. Now see, and I have plus, first of all, the length of the wire is 130, which is 1.3 meters, Shebi. I have it here. Now, change in L, this is the one you're asking me. Change that book. When they give us 130, they did something like plus or minus. They didn't do it.
0.01.
Did they give us check where?
it's only in the load increment and load decrease that they did it.
Let me see. Okay, well, they did not give us, right? But please, this is where our knowledge of foundation and our foundational physics, this is where the knowledge comes in. The thickness of a wire, ball, diameter of a ball, all those round objects, all those things that require accuracy, can be measured using micrometer screw gauge. Hope you know. And we know that the degree of accuracy, reading accuracy of vernier, micrometer screw gauge is 0.001. Shebi? Check. Meter rule is 0.1. Vernier caliper is 0.01. Micrometer screw gauge is 0.001. So that means automatically, since the practical we are dealing with is a wire, I'm using the reading accuracy of a micrometer screw gauge. They did not give me, but that's where the foundation of physics comes in. So I will now use that the degree of accuracy for that wire, L plus or minus, should be 0.001. And please notice, in your notebook, when they gave you length of this thing, wait, look there. That's linear reading. What did they give? Is it 0.01? For linear reading, they just gave you 0.01, Shebi. That means for micrometer screw gauge is 0.001. I said, listen, I said, wire, ball, all those round things. To get the measurement, you do it with micrometer screw gauge, not vernier scale. That one, micrometer screw gauge, that one that looks like yana pochi. So when you come, as you open the ball, you adjust it. It will come and glue it. Let's say I put it here now. It will come and glue it. Then I'll check the reading. That is what you use for ball, wire, anything that requires high accuracy. And we said that the degree of accuracy for it is 0.001. Assuming I checked that error that I have there for vernier scale, and I notice, normally I know that naturally you should know it as a physics student, that vernier scale, the degree of accuracy is 0.01. Assuming I checked it and I noticed that they divided it by 2, that place they included plus or minus for the vernier reading. That means that this one I will also divide it by 2. That means what they are using as our error for all those instruments is simply its degree of accuracy there. That is what they did there, plus or minus. So, but normally I taught them when we started that degree of accuracy, error in all those measurements, instruments is actually gotten by doing the degree of accuracy is degree DOA divided by 2. But I'm noticing that of vernier caliper is just given to me as 0.01. That means they did not divide it by 2. So since I know that wire, to get it is by using micrometer screw gauge, I don't have to divide it, so I'm carrying it like that. So that means that here, I'm coming here to put 0.001. I did not manipulate it. It's just fundamental knowledge. So if I know this, I checked it with the errors given to me. I told you that anytime you're having any measurement and they put minus or plus, and you come and see something like 0.2, this thing is just what they are doing here is telling you that the change in that measurement is simply on the increase is 0.2, on the decrease is 0.2. So the change there is simply 0.2. So that is why I'm using this one as well, like that, for micrometer screw gauge. So now plus 2. Now, my arrow, we got, so, is see? Yes, okay. My arrow, we got it to be 2, shall we? Minus 6, okay. That is the arrow. Now, change in arrow. That time they gave me diameter. There is a place that writes plus or minus 0.2. That thing is simply my change in arrow. I have 0.2. You don't go and apply. The only time you use that degree of accuracy divided by 2 is when they did not give you the accuracy, and you are finding it for everything. Provided they gave me, I will use it. I don't have to divide by 2. Somebody asked what? Diameter, Shebi? Diameter is divided by 2, right? So divide 0.2 divided by 2. Because we already divided this thing into 2 now. So divide this by 2, what do you have? 0.1. Okay, but please, let's check something, no? Let's check something. The radius of that particular wire, Shebi, is the diameter of the wire we are talking about. Is it not true? Yes. That is what they gave us as 0.2 as the diameter. And you know that particular wire is gotten by micrometer screw gauge. Are you aware? Okay, but I'll just go by that based on the fact that they did not give it to me in 0.001. Because we are trying to make sure that whatever examiner gives is what we are using. In as much as we are mixing fundamental knowledge, but I'll divide it by 2. So please, the reason I'm dividing it by 2 is because this is radius. So whatever error I have from this end to this end, when it's reduced, it's like half of it. You understand? So please, still note it. All these things I'm saying, still have room on your notebook to write it. Okay, see, when you use that DOA divided by 2, let's say I come to do this practical. They did not give me any plus or minus. Like, as they gave me diameter to be plus or minus 0.2, they gave me they did not give me 130. Let's say I come to that practical, nothing was given as plus or minus decrement. I will now use my hand to say there are 3 sources of error. No, 4, but majorly 3, because I know that there's instrument error. I know that there's random error, procedural error. And we know that when we did instrument error, we call it systematic error, should we? Was it what we call this? Then we have procedural or human error. So on that error, the instruments that the states are used when calculating this error. So I'm saying, if they did not give me all those plus or minus, whatever, I will not check the instruments used. Vernier caliper, what is this degree of accuracy? I get it. Once I get it, I divide it by 2. Micrometer screw gauge, what is this degree of accuracy? Meter rule, what is this degree of accuracy? Degree of accuracy is simply the spacing, those tiny lines in between. For a meter rule, if I have 0, the next thing is 1, in between is 10. So I will say from 0 to 1 divided by those tiny lines in between is 0.1. So when it's vernier caliper, you have those 10 that is inside meter rule. Then you still have another 10. That is 0.1 divided by another 10. The same thing with micrometer screw gauge. You have 0.01 divided by another 10. So when I've got all those degree of accuracies, I will not divide by 2. But a situation where I am giving like this, I will not make use of what I have. That means I'm coming. That means that in this case, what they are actually using for all these things, if you check it out, you see that what they're actually giving us is just the degree of accuracy has been changing. I ask your question.
So you said the degree of accuracy of that micrometer should be 0.001.
Yes.
So that is the bigger.
Which one? Which one?
The one that is
Okay, wait. This 0.001 is in what? It's in cm. If you convert it to meter, it's what? 0. What? But ask. The length of what?
The length of the wire.
Please, notice something, Notice something, this particular length of wire, which we use, what's it called? Elo, or what's it called? As what? What did they give us there? They gave us value for it now.
Yes, 130 is the length of the wire, not the size.
130. Then that 130, okay, from up to down. Didn't they give us, okay, that's the one we said something about micrometer screw gauge for. Okay, and what we used to get it is actually meter rule, Shebi. That means it's supposed to be 0.1. Very true. It's not the thickness, because what I did here is I judged the thickness. But it's actually the length. Sharp U. Yes. So please, see how we do this so that we don't get confused. Let's draft out all the degree of accuracy one side, all those changes one side. Because as I'm doing this one, I am getting carried away. But see, I have for E, did they give me a change in E? They did not give me. I have for slope. I know that slope, the change in slope will simply be 4W over NR, Shebi? Please, let's do it this way. Then, what's it called? The length. I am giving length to be 130, Shebi? Length of wire now. Length of wire. Thank you very much. We judge this as depth instead of length. So the change in this will be 0.1 and this is cm. Shebi? Then the next one is diameter. Diameter, and this diameter is the diameter of the wire, Shebi. Check for me, is it the wire? Let's be sure. Is it the wire or the mass? Check the book. The diameter of the wire, Shebi. And they gave it to us as, this is where I'm supposed to use that 0.001. I seen it, but in this case it was given. They gave me plus or minus something there. 0. What? 0.2. So, and is in what? Is it centimeter or meter? cm.
As they give, they can use vernier caliper to measure the length of the wire.
You say?
They can use vernier caliper to measure the length of the wire.
Do you know what vernier caliper is? It has the external and the internal, Chevy. Everything that micrometer screw gauge can measure, vernier caliper can also measure it. But when you now say to obtain accuracy, the most, should I say, the instrument used for most accuracy is the micrometer screw gauge. So whenever we are doing practical, and we know that vernier caliper can measure something that micrometer can as well do, we use micrometer for it. It gives a higher accuracy.
No, there's something I'm saying. There's a vernier caliper that is used to measure the length, like the size, not inside the element.
No, now see, is it not the wire we are talking about? It's not outside we are doing it again. The wire itself, the wire now, from this end to this end.
The practical use vernier caliper, not
Okay, the practical use vernier caliper. Whatever they use is now our business, because if you check, they already gave us the plus or minus here.
and they give us plus or minus 0.01.
Is it 0.01 or 0.02?
0.01 in that length.
Blood of Jesus. Let me see this manual. Everybody is bringing his own now. Please, let me just see the manual. Okay, you're using the new one. No wonder. No wonder. See, give me the new one, the old one. The old one. The old one is 0.2, Chevy.
Even the one is
Okay, even the new one, they don't give anything in length, Chevy. Okay, where are you manufacturing your own from? Okay, it's you people that are stressing us now. It's you people, because I didn't look at it. Everyone are open smart. Because if you go to the table on this own, the table is already giving us those degree of accuracy. What we are just doing here is like people that did not give anything. We are doing as if we are struggling to get it. But if you go to the table, they already gave us those things. So you are just suffering me. So this one here, and this one is in cm. So we are going to convert from cm to meter. Unless you want us to use cm, then when you get home, you convert to meter. So please see, everything that we've been suffering to do, all those things we are doing is when they did not give you. It's when they did not give you, that's when you go through that stress. But provided they gave you those degree of accuracy, if you check on the table of value here, they have plus or minus, increments, decrements. So I don't have to be suffering myself to get all those things. So since the sense suffer, we suffered the first time we did this practical. We've done this before now. Who gave me? So, there you have it. So please, that means that since we have all these things, I will convert some things to meter. So please, see what you do for me now. Shebi, this thing is in meter. This one is in meter as well, right? Huh? Wait, this thing is in meter. Check for me. Everything here is in meter, Shebi? Yes. Well, see, it's in SI units. Convert this thing to meter for me. What do you have? Eh? 0.0030. Somebody is asking me what of this one. Are you not noticing that close to the diameter they gave you that one at 0.2? I just divided by 2 for the R, so I have 0.1. So still convert this thing for me to meter. What do you have? 0.001, Shebi? In meter, please. Write it somewhere in your notebook as meter. So please, those confusions that we're having is as a result of the fact that we're trying to derive it ourselves. But book already gave it to us. Okay, so I will come here for change in L. I'll have 0.0001. Then diameter 0.001. Okay, and please, you know that this one is for, that is change in slope is the same as your error in slope now. And I believe you must have done your slope. I believe you must have done your slope. And what did you get as your change in slope? Any value? Okay, let's progress. Can I clean? Let me just clean this. You see that some serious students, they are using their time now to do this practical. Those things they did not convert that time, they are converting it so that they can give us answer. Some people are saying, when I get home, I will cool down and do it. I want to clean this thing. So this is going to be change in E. Please remember I said that this is how you calculate error. This is how I'm coming. This is how you calculate error, not standard error. Sure you remember? But ask. Okay.
When you are calculating that change in R now, when you are dividing by 2, are you not going to divide 0.2 times 10 to the power minus 4 or minus 6?
No, I'm not going to do that. We don't do that. Your values of your negatives, or sorry, your increments, decrements, is simply the plus or minus part of it. It has no business. Because notice, that diameter already is already in times. That diameter we are doing is already in times 10 raised to the power minus 4, should be? So it's the same as saying whatever I have on that diameter is having plus or minus 0.2.
No, like, this thing is inside the bracket, then the 10 is outside.
Let me see what you're saying. Let me see what you're saying. There's not plus or minus.
So it's times in.
That is supposed to be plus or minus. It's just that they made mistake and they wrote plus. So when you are doing your own, you do it, but see what I'm doing. See what I'm doing here. With the knowledge I have, what I'm doing is 4.0 times 10 raised to the power minus 4 plus or minus 0.2. This is what I'm doing. So carry. So please, this is what I'm doing. There is no, I've never seen where you are having increments, decrements, and you are having it times 10 raised to the power, whatever. So this is what I'm doing. This is what I'm doing. So changing this is going to be equals to 0.5 equals to 0.5. Sure, you know that this thing now can times everything here. Times 10 raised to the power 9. Then, if I have this all into 4W all over NR all over 5 times 10 raised to the power minus 4 plus 0.0001 all over 1.3. So you've taken note of this. This is what I'm doing. Then plus 2 into 0.00. If I take account of how they wrote it in that your notebook, we are going to add that times 10 whatever, but I'm not doing that. So my decrement should always be in a fraction, that is in that decimal point. I'm not lifting it to anything. So all over 2 times 10 raised to the power minus 6. Okay, so there you have it. So please, what you don't do for me, why I'm drafting this thing like this is so that when you get home and you are doing this work, what you will not do to make it easy for yourself is simply, the minute you find your error in slope, just come and put the value here, then do all these things, and then you get your answer. Now see, where is that should be this one here. So you remember that this one is the one we divided into. That our 0.2 that we divided into 2. So when you do your own, you do this. Then compare it. So this is our change in E. Is there any other question there? That's our change in E. So please, let's treat the young modulus of a meter rule by oscillation of cantilever. Let's be fast so that we can go. We must do it.